Hello everybody, today I can map a regular polygon onto itself by using 360 over n to find the minimum number of degrees and finding any multiple of that. So this is an important lesson, it's not a complicated lesson, it comes up on the regions like half of the time. I'm not going to go through the full lesson of it, I'm just going to get right to the point. First off, you do need to know some vocabulary. You need to know what a 5-sided polygon is: 6, an 8, a 9, and a 10. 5-sided polygon is called a pentagon. A 6-sided is called a hexagon. An 8-sided is called an octagon. 9-sided, like I never really said you had to know, but it came up recently. The multiple choice answer, a nonagon, and 10-sided is a decagon. So snap a picture or a freeze frame of this if needed. You do need to know this vocabulary for this lesson. So for number 1, what is the minimum number of degrees that a regular decagon must be rotated to be mapped onto itself? Step 1, to find the minimum rotation, I do 360 over n, where n is the number of sides and angles of the polygon. A decagon, we just said, has 10 sides. 360 divided by 10 is 36. That's the minimum rotation. That's the answer. Now, even though that's the answer, understand that any multiple of 36 will also map it onto itself. 36 times 2 is 72. 72 degrees will map it onto itself. 36 times 3 is 108 degrees. That'll map it onto itself. 36 times 5 is 180. That'll map it on. No, that's not right. 5 times, 36 times 5 is 180. That'll map it onto itself. Any multiple of that will also map it onto itself. So it's going to come up later in the lesson. So for the minimum rotation, it's 360 over n. Once you have that minimum rotation, if you want to find other rotations that will map it onto itself, any multiple of that will also do it. Number 2, what is the minimum number of degrees a regular hexagon must be rotated? So a hexagon has 6 sides. Step 1, I divide 360 by the number of sides. I get 60. That's the answer to the question. However, any multiple of that will also map it onto itself. 60 times 2, 120. 60 times 3, 180. 60 times 7, any multiple will also map it onto itself. Now for something like number 4, it says which will have a minimum rotation of 45 to carry it onto itself. So you're going to have to go through each choice. Choice 1, an octagon has 8 sides. Choice 2, a nonagon has 9 sides. Choice 3, a hexagon has 6 sides. Choice 4, a pentagon has 5 sides. From there, we just do the division. You can use a calculator if needed. 360 divided by 8. And again, I'll just show you the calculator, why not? 360 divided by 8 is 45. 360 divided by 9 is 40. 360 divided by 6 is 60. 360 divided by 5 is 72, which has a minimum rotation of 45. Choice 1. Now we get into the real part of the lesson, although they could ask what we just did. Number 6, the regular polygon below is rotated about its center. Which angle of rotation will carry the figure onto itself? Notice it doesn't say minimum rotation, it just says rotation. Step 1, 360 over n to find the minimum rotation. What's n in this example? There's 1, 2, 3, 4, 5 sides. It's a pentagon. I do 360 over n, which is 72. That's not there. Well, 72 is the minimum rotation. Any multiple of that will also map it onto itself. So 60 is not a multiple of 72. So the most efficient way to do this would be to take the remaining choices and divide it by 72. because I'm looking for a multiple of 72. Is 108 a multiple of 72? No. Is 216 a multiple of 72? Yes. I like to go through all four choices, always just to be sure. Is 540 a multiple of 72? No. 72 times 3 is 216. Therefore, the answer is choice 3. So 360 over n will give you the minimum rotation. Any multiple of that will also map it onto itself. So you have to find which one's a multiple. The easiest one is to use the calculator to divide. Which rotation would map a regular hexagon onto itself? Well, step 1, 360 over the number of sides to find the minimum rotation. 360 over 6 is 60. I don't see that there, so it can't be 45, it's smaller than 60. So which of these is a multiple of 60? You may be able to know the answer just by looking at it, but if you don't, let's go through all the choices. 150 divided by 60 does not go in evenly. 240 divided by 60 does go in evenly, so that one looks good. 315 divided by 60 does not. Your answer is choice 3. I think at this point we get the gist. I'll go over one more though, why not? Which will carry a regular decagon onto itself. If you're still following along, I would pause this and try this one on your own at this point. To find the minimum rotation, 360 divided by the number of sides. Decagon is 10. That's 36. It's not there, so I'm looking to see which of these is a multiple of 36. So is 54 a multiple of 36? No. Is 162 a multiple of 36? No. Is 198 a multiple of 36? No. I sure hope it's choice 4, or else we got some problems. Whew. Yes. 36 times 7 is 252. 252 is a multiple of 36. Therefore, it will map it onto itself. So, to find the minimum rotation, we do 360 over the number of sides. Once I have the minimum rotation, any multiple of that will also map it onto itself. So you need to find which of the choices is a multiple of the minimum rotation. Practice it, very important as far as the regions goes, which means you're going to see it a lot throughout the year with me. Have a nice day.